Hey all, hey all. My name is Paul, and this is my e-record for the data structures lab. And the program that I've been given is for the is to implement selection sort and insertion sort. As the name suggests, these are sorts that are used to sort elements either in ascending order or descending order. Now, without further delay, let's move on to the code which I have created for executing the same. This is the code I've made. I've declared an S3 header files, and then I've declared the functions that I am going to use, and I have declared an array and its size. I have declared global, and in the main function, I've declared the necessary variables, and I've started a while loop while x is equal to y. This will let the user to ask the user whether he want to continue or not. And after that, I call the get function. As the name suggests, the get function, it's a void without any return type. It's used to get the value of the array, the size as well as the elements from the user, and store it in the int AR of 100. Now, after that, I ask the user how he wants to sort the array he has inputted. If it's for selection sort, he can enter 1, and if it's for insertion sort, 2. I use a switch case to get his choice, his or her choice, sorry. And then if it's the case is 1, then I call the cell sort function. If the case is 2, I call the insert function. Now let's move on to the function that I created. Void get, I've done this before, you have all seen earlier. This is like the typical way to get an input an array using a for loop. And in the void cell sort, this is a selection sort. This implements the selection sort module. Now we need two for loops, and int min equal to I. For the first for loop ranges from I equal to the whole array. The second for loop that moves from the element next to I to the last element, and it checks whether min is equal to like if AR of j, that's the next element, is less than the current element, and if so, then the min is repositioned, that minimum value is repositioned to that position, and if not, and after the end of the second loop, then the swapping takes place between min and the current min and the current I, a of I, and then the element is counted, and then void insert. In this case, we need an int temp variable, and we need again two loops. The first loop, it moves from I equal to 1 to size, that's the whole loop, and then the next one is an decrementing loop. It starts from j equal to I, and as long as j is greater than equal to 1 and j is decremented, it goes behind the current element. It goes like this. And in this case, it checks if AR of j is less than AR of j minus 1, and then temp equal to AR of j, swapping takes place. Then AR of j is equal to AR of j minus 1, and AR of j equal to minus 1. That's the swapping takes place. And if not so, then break, and then the control comes out of the loop, and then we use another for loop to print the array. And that's it. That's the end of the whole loop, whole code. Now let's try running it, and hopefully it will work perfectly. Now let's run it. The compiler is asking me what the size of the array that I'm inputting. Enter the array. Let's give 1, 2, 6. Okay, let's try selection sort first. 1, 2, 5, 6. It has sorted in ascending order. Now yes, I want to continue. Okay, let's give the same array again. 1, 5, 2, 6. Oh, sorry. I always mess with this one stuff. 1, 2, 5. 5, 6. 1, 2, 5, 6. Yeah, there it is. How do you want to sort it? I want to sort it using insertion sort. 1, 2, 5, 6. Oh, I gave sorted array. Let's just do it again. Enter the size of the array 4, 1, 6, 3, and a 5. 2, 1, 3, 5, 6. Now it got sorted. So hence it's proof that all my modules work perfectly. So I'm exiting, and that's it. Thank you all. See you next time. Thank you all for watching. This is Paul signing off.